Number 2 is talking about angles, and this says the difference. Stop right there for a second. What does difference mean to you? Subtraction. So let's remember that. That's pretty important. The difference of the measures of two. Here's another really important word. Complementary. Does anybody know what complementary means?
Together, don't they make a number?
Specifically, which number?
That it would be like, oh, I'm giving you a nice compliment.
No, wrong complement.
Yeah,
It's not 180. It's
90.
The A
90.
that makes it, they help each other.
So complementary angles
No.
add up to be 90 degrees. Complementary angles add up to be 90 degrees. So it says the difference of these two complementary angles is 64 degrees. Find the measure of each angle. So when that question on the video about the plumber trying to cut the pipe into two parts, I brought up the idea that sometimes a picture is worthwhile. Do you think a picture is worthwhile here? I think it is. I mean, you might say no. I think this could go either way. I think a picture is worthwhile, and here's what I would do with a picture. I would make a right angle, because I know that complementary angles add up to be 90, and I would just draw those two angles by, doing something like this. I would call one of the angles X. I'd call the other angle Y, and I would use this to kind of help me get things started. Okay? So it's a really basic picture, of course. I do have my right angle up there, and I've split it up into two angles. But I think this could be helpful. So I'm told two things about this. Number one, I'm told that they are complementary, and complementary angles are angles that add up to be 90 degrees. So can you write an equation expressing that these angles are complementary? What might that equation look like? Go ahead.
X plus Y equals 90.
Yeah, one angle plus the other angle has to equal 90. That make sense? Complementary angles are... Could you stop with the water bottle crinkling, whoever that is? Looks like it's Alec. There we go. Thank you. Yeah, complementary angles are angles that have to be 90 degrees, and so if I take one angle plus the other one, I have to get 90, don't I? Now the other statement is, I'm told that the difference of the two angles
X minus Y.
is 64. So say it again, Grace.
X minus Y equals 64.
That's exactly right. X minus Y equals 64. So what I've done is I've written a system of equations. Let's review. What is a system of equations? Two or more equations. Two or more equations. You see how I've written two or more equations? Two or more equations. What are the three methods that we have learned to solve systems? Graphing, elimination, substitution. That's right. Graphing, elimination, substitution. Looking at this. Did you have a question, Cole?
Oh, no.
Looking at this, Cole, what do you think would be the best method?
Elimination.
I think elimination is the best method. I think substitution would work really well also, but I think elimination would probably be best. Cole, when I do elimination, I'm going to add. And when I do that, what do I get?
2x equals 6.
What?
I like it so. 154 is right. Okay, so if 2x is equal to 154, my first goal would be to get the x by itself. I need to divide by 2. That's right, Hosanna. So I divide by 2, divide by 2. And what is 154 divided by 2? Say again?
77.
77 is right. Okay, so that means x is equal to 77 degrees. That's that angle. How do you think I could find the y, the other angle, to go with that? Say it one more time. That would work. No. Well, so Ashlyn, what's the overall principle? What am I doing with the 77? I'm plugging it in, right? Which one do you want to plug it into? Okay. So if I plug it in the top one, I would get 77 plus y equals 90. And then what do I do with 77? There you go. So I think you were on the right track with what you originally said, but it seemed like you weren't like actually plugging it back in. You were just kind of thinking about it. And thinking about it is not a bad thing, but I kind of like plugging it back in. So, sorry, that's kind of off the side of the screen there. Y equals 13. There we go. So that means x is 77 degrees, y is 13 degrees. What do you think? Yeah, question, Cole.
Oh, can I use the restroom?
Yes, you sure can. Any questions pertaining to this question? Go ahead.
Can you write it in like the?
Oh, the ordered pair?
Yeah.
You know what? Since we called them X and Y, you sure could. 77, 13, something like that. I'd be okay with that. Yeah, that's fine. It didn't ever say that they had to be X's and Y's, but I mean, I think that I would definitely take that for sure. Anybody else? Okay, hope that was a good warm-up for you. Let's do at least one more. We might do a little jumping around here. Yes. So I'm going to just let you guys run with this one for a couple minutes, I think. Yeah. So let's look at number 3. This one says a pet owner wants to make a rectangular. That sounds pretty important to me.
Yeah.
Rectangular dog run from 28 feet of fencing. If the length of the dog run is to be 10 feet longer than the width, find the length and width of the area that is enclosed for the pet. So can I just, you've seen the one on the video, and we just did that one together. Can you guys try this one on your own? Kind of a different situation. Give it a shot. Ready to go. Guys, check this out. First thing we're going to do is we're going to draw a picture.
Yeah, I think.
So we've got this rectangular dog run. I'll just do this off to the side, and I'm going to keep the labeling of this super duper simple. I'm going to call this X. I'm going to call this Y. And since this is a rectangle, that'll also be X and that'll also be Y. Does that make sense? I'm going to go super simple. There was a lot of folks, as I was walking around, a lot of folks were trying to substitute right away under the picture. I'm just going to say, I got 2 sides of X, I got 2 sides of Y, and that's it. I'm going to keep it really, really simple. I know a couple things about this. I know that the length is to be 10 feet longer than the width. So I'm going to say that X is equal to Y plus 10. Does that make sense for my picture? The length is 10 more than the width, so X equals Y plus 10. And then I know that I have 28 feet of fencing. So that means if I add up all the sides of the enclosure, that should add up to be the amount of fencing that I have. And so it would be X plus Y plus X plus Y is equal to 28. That makes sense? So I'm going all the way around. So I've got X plus a Y plus an X plus a Y has to equal the full amount of fencing. So really, what's the concept we're talking about here when I go X plus Y plus X plus Y? It's perimeter, yeah. So I'm basically saying the perimeter has to be 28 because that's all the fencing that I have, and I'm presumably going to use it all. So instead of this, then I could write this, 2X plus 2Y is equal to 28. Make sense? Okay. So at this point, I've got my system. How do I know that I have a system of equations?
And there's more than one.
Yeah, I got 2 equations up there, right? There's more than one of them, so it's a system. I could use elimination, substitution, or graphing. Which method strikes you as the easiest method looking at the setup up there? Substitution. Why do you say that, Kendall?
Because the X is already solved.
Yeah, the X is by itself. That's exactly right. So if you guys did not get a chance to solve this, please take a minute, use that setup if you want, and solve this system for X and Y. Go ahead.
So I think like a different way.
How this works. Substitution, I think, is earlier suggested. Hey, guys. Hey, had plenty of time. I think you would acknowledge that. Now let's pay attention, make sure we're good. Substitution, I think, is the way to go. So what I can do, because X is equal to Y plus 10, that means in the other equation, wherever I see an X, I can replace it with Y plus 10. So I'm going to do just that. So I'm going to write 2 blank plus 2Y equals 28. You can see at this point that I have removed the X from that equation. There is only one thing I can put in place of the X, and that would be? Why can I put in Y plus 10 for X? That's what they're equal to each other. That's right. So Y plus 10 goes here. What property needs to be used now? Yep, that's very common. So you get 2Y plus 20 plus 2Y is equal to 28. Oh, didn't quite fit that in there. There we go, 28. Do you guys see the like terms on the left? Let's add those up first. What's 2Y plus 2Y?
4Y.
So you get 4Y plus 20 is equal to 28. We subtract 20 from both sides and we get 4Y is equal to 8. We divide both sides by 4, and y is equal to, ooh, that is a skinny dog run, isn't it? 2 feet. Okay, and so we found the y. How do I find the x? Plug it back in, and isn't this the easier one to plug back into?
Yeah.
X equals y plus 10. So I'll come over here and do that. X is equal to 2 plus 10. So x is equal to 12. So this dog run is 12 feet by 2 feet. So this had better be a pretty narrow dog. 2 feet's not very wide for a dog.
My dog could probably.
That we still have 2 examples here, I think. We got number 4. We got number 5. We'll be doing numbers 4 and 5 on Wednesday of this week. I'm going to skip ahead. Do I want to? Let's do this. This will be, guys, this is actually going to be really, really good for you. This will end up giving you 3 different touches on this. This is going to be really good. Would you skip ahead to number 2? There will be a video for this as well for Wednesday. But if we could get a little touch on this today, and then you get a video, and then we go with Wednesday again, that'll be 3 touches in 2 days. That'll be pretty good. So if you would, take a look at number 2, flip over to that 4.5 section. I'll give you just a second to do this. And I want to teach you how to do this. Hopefully you can watch the video again maybe tomorrow, or watch the video tomorrow, see this sort of thing again, and you can be super solid with this for Wednesday, and I think we'll be in a really good place. Here we go. It says, graph the solutions of the system. We've done this before, but we have not done this before with inequalities. Right? So, anytime you have a linear inequality, that brings into play 2 different things. That brings into play shading and also the dotted solid concept. So we want to make sure we remember to think about that. So we're going to graph this. It's going to be pretty simple as far as how we present our answer. We're going to graph this. And of those 2 lines, which one do you think is in the easier form right now to graph?
Bottom one.
Bottom one? What form is the bottom one in?
Slope intercept.
Slope intercept. All right, fair enough. So let's graph that one. I will graph this one in red. Here we go. What is the y-intercept for that bottom line?
0.
Y-intercept is actually 0, right? Because it's y equals mx plus b. There is no plus anything. So I'd say the y-intercept is 0. So that's going right about there. What is the slope on that red line? So that means I need to go up 2, right 1, up 2, right 1, and I'll just keep going in this pattern. And I'll go all the way through the graph. So that's just using slope-intercept form to do that. I'll just leave it at that for the moment. That make sense? Any questions? I've only done the red line. We'll do the other line here in a second. So since you guys don't have any questions, let me ask you a question. Should I leave that line as is and leave it as a dotted line, or should I connect all the dots and make it a solid line?
Dotted line.
Dotted line
Yeah.
or solid?
Dotted.
Why dotted?
Because there's no line under it.
Yeah, if you look at the inequality, there is no or equal to in there. And so, I mean, this is hardly mathematic, but if you look at it and you say, hey, if there is a line under the or equal to, it needs to be a solid line. And if there's not a line under the greater than or whatever, then it needs to be dotted. I mean, it's just a good way to remember it. But you're right, it has to be a dotted line. The final thing we got to do is we got to decide shading on this. So, how do we usually decide shading?
Plug in.
Plug something in. What do we normally plug in? 0, 0, right? So x is 0, y is 0. Why is 0, 0 not going to help us here?
Because it's on the line.
It's right on the line. So, Ashley, do you have a suggestion as to what we could plug in? 1, 1.
Still can't.
A 1, 1 is pretty darn close, I would say, to the line. I mean, it looks like it's on that right region, but do you see how 1, 1 is still really close? Say again?
2, 2.
2, 2. I'd say 2, 2 is still
0, 1.
close. How about 2,
1, 3.
1, 3, 2, 1,
0,
4.
1, 0, 1.
You know what? The best one I've heard so far, I think Alec came up with it. How about 0, 1? Isn't 0, 1 right? Did somebody else say that? Sorry if I didn't hear you. Sorry, Hosanna. Hosanna beat you, Alec. Good suggestion, Hosanna.
What?
0, 1 is right there, so I think 0, 1 is an excellent test value. Here we go. 1 goes in for y. 0 goes in for x. 1 is greater than 0. Is that true or false?
It's true.
It is true. So we are going to shade on the side that had the 1, 0. And so that would be this side over here. Let me try to do this. Over there. I'm going to shade that half.
What?
Who said what?
So if x is 0 and y is 1,
Yep.
then
So
it should be over 0 and up 1, wouldn't it be the other side?
so 1, 0.
Wouldn't you shade the other side if it's moving?
1 0, not 0 1.
So we did 1, 0 and 1, 0.
One is Philip, one is...
I'll put up 1, 0 in there in green. So 1, 0 is right there.
Yeah.
So of the two regions we have up there, let's call this region A. This is region B up here. Do you see how 1, 0 is in region A?
Yeah. I thought, you're saying that y, you plugged the 1 in for y.
Yeah.
And
So wouldn't you go up 1?
Yeah, it'd be
go
one
this
over
way.
there, so it would be.
Oh my goodness, Grace, I did plug in the wrong thing for the wrong thing.
I was right.
Yeah. So 0, let's see here. So my test value, let's make sure this is right. If I messed up, let's fix this. So we want to use 1, 0. So that means x is 1 and y is 0. You know what? I did flip those around. So it'd be 0 is greater than 2 times 1. 0 is greater than 2. Is that true or false?
False.
That's false.
So it's on.
And so that means this region down here, region A, is not it. It has to be region B. Grace, thanks for saying something. That just slipped right on past me, and I was going to go on my way. Thank you for saying that. Okay, so does that region make more sense to you guys? Okay, let me clean that up a little bit. Something like that. Okay, so now we got to graph the other line. Is the other line in that nice form that we've seen?
No.
It's not in slope-intercept form, but it's actually in a pretty nice form. You guys realize you could use intercepts to graph this?
We could.
I don't know. You guys are always so resistant. You've been so trained to do only slope-intercept. But check this out. If I want the x-intercept, what do?
Plug 0 in for y.
0 in for y. So check this out. 3x is less than 6. X is less than 2. That means my x-intercept is 2. Oh, goodness. Let's review. To find the x-intercept, what do?
Plug in 0 for y.
You with me, Hosanna?
Yeah.
Okay, so that would be 3x plus 2 times 0 is less than 6. 2 times 0 is just 0. So you get 3x is less than 6. Divide by 3, and I get an x-intercept of 2. So I could just come over here and put a point right there at the x-intercept. To find the y-intercept, I plug in a 0 for?
X.
For a y-intercept, plug a 0 in for x. So it would be 3 times 0 plus 2y is less than 6. 3 times 0 is 0. Dividing both sides by 2, I get y is less than 3. That means my y-intercept is
3.
So that is up here, like so. So you can see the slope here is negative 3/2. So I could continue on here and do something like this, and like that, and like that.
So required to even do that, you just find the slope intercept form.
Well, you could do slope-intercept form here. I think intercepts is easier because you just go plug, divide, and you got it. But you could do slope-intercept form, no problem. Another question I'd have for you is, with this top line, this purple line, do I need to fill in and connect all the dots? Or do I leave it dotted?
Leave it. 'Cause it's not equal to or greater.
That's right. So you leave it dotted because it's not or equal to. And then let's see if I can get this one right. We need to shade. What would be a really good test value for shading here?
0.
Not 0.
0 0.
0, 0, yeah. So if I use 0, 0, that gives me 3 times 0 plus 2 times 0 is less than 6. So that would just be 0 is less than 6. Is that true or false? It's totally true, isn't it? So the region containing 0, 0 would be our answer region. So I'll shade down there. So I think my shading would be along this. Let's try that one more time. Okay, so then how do we answer this system? The answer to the system is actually where the shadings cross. Can you see where the shadings overlap?
Cross is this region.
In the top region.
No, top left.
It's,
Far
it's,
left region.
I think it's just more like left, isn't it?
Yeah, the left region.
I'll put in some black lines to make this a little more clear. I would say that this region over here is where the shadings overlap. And so where the shadings overlap, like that's your answer, right? So we're not going to list out numbers here. It's simply going to be your graph where the shadings overlapped. That's your answer region. So a way that I could ask you this question is I could give you a graph and I could label this as region A, this is region B, C, and D. And I could say which region is your answer region. And you would say
D.
D. D. Yeah. Does that make sense?
A, B, C.
D.
Any questions at all?
A, D.
All right, fair enough. Let me see what I want to do here. We got about 6 minutes to go, 5 or 6 minutes. I like this one. Let's take a look at example number 3. Why don't you guys try this one on your own? This is some different looking lines, but they're simple enough. I think 5 minutes is enough time to have a shot to do this. We'll give it a try here. So it says, graph the solutions to this system. Y is greater than or equal to -2. X is greater than 1. So the top line there is horizontal. Y is greater than or equal to -2. And I will represent that with a blue line. It is also solid. It's going to look something like that. And when you try out 0, 0, is 0 greater than or equal to -2? I asked you guys a question. Is 0 greater than or equal to -2? It is, so that would be true, wouldn't it? Yeah. So I'm going to shade on the origin side. I'm going to shade up here. Then the other line is x is greater than 1, so that's vertical. And that's over here. It's going to be a dotted line because I don't have the or equal to. Yeah. So it's a dotted vertical line over there. And then the 0, 0 test is 0 bigger than 1. It's not. And so when we shade, we're going to shade on the non-origin side. So I'm going to shade over here. And now you can see where the shadings overlap would be kind of that upper right region. That would be where your answer region is. So what that means is that any point, bless you, any point that you pick out up there, any of these points that I'm putting dots on, any of these points should work in our system of inequalities, should work in both inequalities, no matter what, right? Any point in that region should work, okay? All right. Hey, I'll see you guys on Wednesday. Don't forget to watch your video for Wednesday, and we'll get this thing finished up mostly on Wednesday. Have a great day.